My presentation is on creating digital arts in the math classroom. It is actually a presentation I came up with and presented last year at the TIES conference in Minneapolis. And so I decided to kind of revisit this and look at what we can do with digital arts. Um, oh, all right. So the two tools I used to create the different art projects were Desmos and Code Studio. Desmos, I say art with functions, but actually have an example with some conic sections as well. And it uses equations to create lines and pictures on a coordinate plane. And then Code Studio Artist uses it's through Code Studio, which is also the people that do Hour of Code, and they have a art tutorial that then after completing the tutorial, you can do more things with that. And this one I feel is more geometry based. Need to know some different properties of shapes, need to know angles. So I think of these as one being algebra and one being geometry. So first, just some examples of the Desmos art here. This is usually one of the first projects I have students do when I'm using Desmos to do art in the classroom is a house. It's all straight lines, pretty basic and easy, and then students aren't worried so much about the equations and they can focus on some of the Desmos features they need to learn before doing anything more advanced. So different things we're gonna look at when we try color, these intervals right here that allow you to limit the line to only a part of the graph instead of continuing in both directions. I do notice on these first ones, I don't have them quite in notation form without that y equals, but Desmos is able to handle that and you can leave that off. I'll also talk about sliders and how those work in Desmos. My other example here is not function based, but conic sections. And so I'll do this with my Algebra 2 advanced classes. And what's great about Desmos and conic sections is that you don't have to solve for y. So looking at the first one here, we've got our circle, but unlike a graphing calculator where you have to do the positive square root and the negative square root to get the full circle, Desmos is able to recognize that equation as a circle and put that all in there. So here we've got circles, ellipses, parabolas, a bunch of different conic sections creating our smiley face. And kind of like I use the house as our basic one for functions, I use a smiley face as our basic one for conic sections. Here's just an example of some student work, and this was actually created by putting an image down first, and then the student used equations to trace that image. They were able to get some shading by using inequality signs versus equal signs, which is fun. Yeah, so some of those things I've talked about, and I can demonstrate here how to add an image using the bracket to do the interval. Changing the color, you just click down on the color, hold it down, and choose whatever color you want. And then using sliders is how I kind of play with the equations to get it just where I need it before typing out the equation. And getting the shaded regions by using inequality signs. So let's go to Desmos here and play around a little bit. So let's say we wanted to trace an image. So I've got to upload the image into the background of your graph that you're going to want to draw over. You do need to have that image ready. So I'll usually have students pick a cartoon, have something, and download it onto their computers or iPads, and then you need to upload that. So here is just an example of a snowflake we could trace. You can adjust the size. When I first started doing these projects, the image could only be at the center, the origin here. But say you wanted your image entirely in the first quadrant, you can move that over there and have the students work with it there. I kind of like it at the origin because then it does encourage them to use some positive and negative aspects of the graph. So you can adjust where that center is. And then let's say I wanted to try and trace this positive line increasing from the third to first quadrant here, but I wasn't quite sure of the slope. So you can type just a generic form of a line and then use the sliders to kind of adjust things around and get it where you want it. So one thing I usually do when I'm working in Desmos, and it started by having to present it on the board all the time, but I like this projector mode because it makes the lines a little thicker, a little easier to see and work with, even when I am just working on my own personal computer. So we've got our line, y equals mx plus b. I do know that the y-intercept is the origin, so I can adjust that. But here, let's say, I mean, that is pretty close, but let's say I knew my slope was between 0 and 2. I could adjust the slider to only be between those two numbers, and I could say what decimal value I wanted it to count by. So here, as I jump along, I can get more accurate instead of having it go from -10 to +10. So it looks like 1.75 matches that pretty nicely. So y equals 1.75x. So I only want this line to go from down here to up here. So I'm just going to kind of hold down, and that looks like an x value of about 2.5, 2.55. So using brackets, we can set the interval for the x value. You can turn off different lines. Say when you're all done, you don't want this picture to show up in the back, you can turn that off. One thing you cannot do in Desmos, you can't change the weight of the lines. So I could set these back to thin by getting it off projector mode, but I can't have a mix of thick and thin. All the lines are going to be the same weight here. Using the intervals here, you can either use the x value or you can use the y value. It doesn't matter which one, whatever you want to do. And for different things, it's going to make more sense to talk about the x or the y. Yeah, as I presented this at the TIES conference, after going over some of these basics, I just gave everyone in the audience just time to play around with it, come up with their own image and start getting some lines on there and just see what sort of things they run into as they graph their art. I am logged in right now using my Google login. And so when I do this in class, I have my students log in. That way you're able to save graphs and work, so they're there when you come back to them the next day. And then here, the share graph, you can either email me a link to it or just the image. As a teacher, I wanted to see the equation, so this email is a better option. The image is literally just the finished image, which unfortunately I want to see the math behind it, what they came up with. So if they email it to a Google account, you can just save it right there to your Google Drive. And yeah, this is something that any algebra student, anyone who is familiar with graphing on a coordinate plane, can make this meet their level. They can make it as hard or as simple as they want it to be. Actually, one thing that's kind of fun, using the sliders, and I don't have anything super exciting right here, but you can set different things to move. I had a student create a train that actually crossed across the y-axis by pushing play on the slider. So students can get very into this. That's pretty fun. All right, so that is Desmos. The other option I presented was Code Studio. Code Studio, like I said, are the people behind Hour of Code. Here are a couple examples. So where that snowflake screen grab came from is this piece of code. And like I said, I consider this more of a geometry-based one because students need to know about tessellations, need to know about other transformations and different angles that make different shapes. All right, so here is the snowflake, and we can actually click on how it works to see the code behind it. All right, here's the code that went into creating that snowflake, and it's actually not too long because it's mostly just repeated. If you watch how the snowflake is created, they make the one branch and then just rotate and make all the other branches. All right. So for students who work on this, if you go to code.org, they do need to be signed in. So that's one thing that's important. Yes, they can start the artist tutorial, which is where I do have my students start. But if they aren't signed in, when they come back to do harder and more advanced stuff, it will make them repeat the tutorial. So that's very important. Have students sign in so they can pick up where they left off. So it's going a little slow here, but let's see what we can do in this tutorial. All right, the first thing the tutorial is going to have us do is create a square. So like I said, Code Studio uses block coding, so it's got all these pre-created blocks that do different tasks. And so you just need to put them together to create a shape. So here's our little man with his pencil. So he's going to move forward 100 pixels and then move forward and then turn until he's gone all the way around the square. So right now I've got 3 moves. I need my 4th one. And there we go. All right, so students will work through this tutorial, and when they're done, they can go into just their artist creator and do whatever they want. And there's going to be more than these limited block options. There's going to be a lot that they can work with. All right, so like I said, students do need to have an account and be logged in. Try that artist tutorial, and then they're going to be able to do more on their own. And so a lot of geometry functions, features, tessellations, rotations, you can even get into fractals, or just free draw. Draw their own cartoon, draw anything they want, are all different things students can do using the block coding. So Desmos to share their work, if they're logged in, is pretty easy. They could also just share the link on the top. Code Studio, when you click share, you can either tweet it out or just copy the link. Unfortunately, there's not the email option that Desmos had, but they can put that copied link into maybe a Schoology assignment or something, some other method of turning it in. All right, so that is my presentation, and just fun things you can use in the math classroom to be a little bit more creative, which is not always something we get to do in math. So thank you and have a good night.